Hello and welcome back to Flaming Dev Studio. This is the first video of Python Intermediate class, which you can find in our playlist in the future. We will be teaching important components of programming, which can make you a better programmer and prepares you to become a great programmer in the future. Now, today we're going to be talking about computational thinking. And before all that, I suggest you all should use JetBrains. The JetBrains tutorial has a complete and full set of tutorials to teach you what you need, like classes, functions, and methods. What I will be doing in this playlist will be to explain these tutorials more efficiently and more easy to be understood. Now first, I'm going to talk about components of computational thinking. Computational thinking is a set of skills. It can help you to come up with a generalizable solution to a problem and solve it using a computer. There are four main stages: abstraction, decomposition, pattern recognition, and evaluation. Now first, for decomposition. There are complex problems in life. You can break them down into smaller subproblems and separate steps. You can solve them easier by solving the subproblems one by one, so it won't sound as hard. Like a math question. Look at this equation below. 4 plus 3 bracket 2 plus 3 bracket. You wouldn't just immediately solve it. You would break it down to steps. First, you need to calculate the brackets. Now, after you've broken the brackets, you can add them all up. This is called decomposition. Now, for the second part. It's extracting and generalizing patterns, which is pattern recognition. Pattern recognition is based on 5 key steps. Identify common elements in problems or systems. Identify or interpret common differences in problems or systems. Identify individual elements within subproblems, describe patterns that have been identified, and make predictions based on identified patterns. Now, what are patterns? Patterns are something you can guess similar point in all these problems. As you can see, subproblems have common differences. You can solve them both by using pattern recognition. Like, for example, if you need to cook pepperoni pizza, you would need to make a flat pizza bottom. A bottom is a pattern shared among all the pizzas, so you can generalize this pattern. You can reuse other information and steps you took for preparing pepperoni pizza. Now, third is abstraction. In the question, there are a lot of information you could take in, but not all of the information is important or useful. You should only have the necessary details. So get rid of all the unnecessary details to focus on what's actually important. You can say that programming language is abstraction. Now, abstraction can help you a lot. Like, for example, a math question. There are a lot of information, but you only need to take in the steps, like linear equations. You see the question has many variables and things, but actually you just need to find how to create the equation and solve it. This example shows clearly. We come back to pizza now and try to apply abstraction. We would say that for pizza to be a pizza, it needs flat dough, sauce, or toppings. Now, in a chef recipe, a pizza recipe could be very, very long, but that's all the necessary details we need to know. Now, for the last one is evaluation. You have found a solution to your problem, which is the algorithm. This algorithm should be easy to understand, complete, and efficient. Now, why should it be efficient? You should be making the best of the tools you have and using appropriate syntax constructions. One day, if you become a professional programmer, you might be working with acquaintances. Acquaintances have to also read your code. If your code is hard or difficult to read, it will waste time and lower efficiency. This will lower work production. So, appropriate syntax can give productive code and also speed. The same code can be written with different ways, but which one is the fastest? You have to use the fastest way to reach your method. Now, for example, this project I'm working on, the bill splitter. There are many ways to do the project. If I put all these parts, I assume you all should know this, but just pretend this is just some random code. If I put it in a function, I can reuse it later, so it is easier. But if I just put these code outside of it, I can't reuse it. I have to copy and paste again, which makes inappropriate syntax. The code is long, hard, and unreadable. That's why I should put it in a function, and if I have to use it later, I can reuse it again. Now, I'm going to talk about the conclusion. Since computational thinking is a skill, it requires lots of practice before you can easily apply it. When looking at a problem is that you don't know how to achieve the result. Use the algorithms and keep on breaking the problem down. You should keep trying this in real life. When facing problems, this is a very useful and effective skill. And that's all today for Flaming Dev Studio. Make sure to like, subscribe, and hit the notification bell. And to tune in for our next video. Bye!